Hello, this is Robert, and in this video I would like to show you a couple of plugins that I have installed that makes Vim a better environment for writing code. I'm using Vundle as my plugin manager, even though Vim 8 and NeoVim can handle their own plugins. So let me demonstrate the two plugins that I have installed. One is for Autosave. And so if I go to insert mode and I make some changes in my code, as soon as I go back to normal mode, the file will be saved automatically. And so that's the Autosave plugin. The other plugin that I have is called Syntastic, and it is a syntax checker, also called a linter. So let's put a syntax error in my code right here by deleting that semicolon. And when that happened, Syntastic noticed that there was a syntax error, and so it popped up a split window and let me know where the error was. Okay, so those are the two plugins that I have installed. There are many plugins available for Vim. Some of them will be for languages that you might be writing in, and some of them might be for other languages. So you can pick and choose which plugins you select for your installation of Vim. In order to install Vundle, you have to have Git on your system. Git is fairly common, so you probably already have it on your system. In the next part of this video, I'll show you how to install Vundle and the other plugins. This is the website for Vundle, and as you can see, it's on GitHub. There's the entire URL, and once you're on this page, installing Vundle is very easy. As long as you have Git on your system, you can just copy this statement from the website right into your terminal. So let's switch to the terminal, and if I just paste it right there, that's the statement that will install Vundle onto your system. If you don't have Git already on your system, then you can install it with your package manager, whichever package manager comes with your version of Linux. And Git is also compatible with Mac OS. So after you execute this statement, you will have a new directory in your home directory called .vim. And so this directory right here is where Vim will be set up, along with the plugins that are installed with Vundle. I've already installed Vundle, and so if I execute this command again, it will just warn me that the Vim directory already exists. Okay, let's take a look at the Vim directory. So cd.vim, and then there's a bundle directory here, so cd bundle. And inside of this directory, we have Vundle Vim. So this is the plugin that comes with Vundle, and it's required. And then I have Autosave right there, and then I have Syntastic loaded as well. So each plugin will create its own directory inside of the .vim/bundle directory right there. Now let's take a look at the website for Syntastic. So this is the website for Syntastic, and really the only thing we need from Syntastic are the recommended settings. So here are the recommended settings for Syntastic. And so basically what we're going to do is we're going to take those statements from this website, and we're going to basically copy that into our .vimrc file. Vundle also has some required settings for the .vimrc file, and they are right here. So these settings from here down to the bottom need to be copied into your .vimrc file. So in the next part of this video, I'm going to open up my .vim.rc file and we'll take a look at some of the required and recommended settings for both Vundle and Syntastic. In this terminal window, I've opened up my .vim.rc file. And this section right here is the beginning of what is required by Vundle down to this line right here. So these statements are basically copied off of their website. So basically all I did was copied the required statements from the Vundle website and then just pasted it right into my .vim.rc file. So if you have any other settings in your vim.rc file, just place the Vundle settings right after it. Let's take a look at some of the optional things that are part of Vundle and some of the things that are required. So from the website, everything from this part, set no compatible, down to Vundle end and file type plugin indent on, that's required to be in your .vim.rc file. These plugins, except for this first one, this plugin is required by Vundle. These other ones are optional. So Vim Fugitive, command-t.get, and these other plugins, these are just examples of plugins that you could have in your vim.rc file. So let's switch to my .vim.rc file and take a look at the plugins that I would like to have access to. This is the one that is required by Vundle, and then these other two plugins are the ones that I would like to have for my specific installation of Vim. There are a lot of plugins, and if you want to add more to your .vim.rc file, just add them in one right after the other. Okay, so I have the Syntastic plugin, and then I have the Autosave plugin right there. For Syntastic, there are some settings that are required or recommended for Syntastic as well, and this is the section of my .vim.rc file that is for Syntastic. So let's take a look at the Syntastic web page and take a look at their recommended settings. So in section 3 of their web page on for Syntastic, and that's also on GitHub, and there's the URL right there, they recommend that you have these settings in your .vim.rc file. So right after my Vundle settings, I have my Syntastic settings in my .vim.rc file. So these are just copied right from the Syntastic website. In the next part of this video, we'll take a look at how we can install those plugins using Vim, and then we'll take a look at some of the other features that we have with Syntastic and Autosave. And then the final part of this video will be the mappings that I have turned on for some of the programs from inside of Vim. So I can compile my code right inside of Vim. I can run the executable, and I can start up GDB, etc. I can call make from right inside Vim. This part is not part of Vundle, but it's a very it's a great feature that we can start up programs from inside of Vim. We don't even have to quit Vim in order to compile our code if we have these mappings turned on. Okay, so in the next sections of this video, we'll take a look at those items. After you have your .vim.rc file set up to have access to Vundle, and after you install it using Git, there's just one last step that you need to do in order to have access to your plugins, and that is to launch Vim and use the command plugin install. After you type that command in normal mode in Vim, your plugins will be installed, and then after you restart Vim, you'll have access to Syntastic and Autosave and any other plugins that you might have access to. So that's the last step for having access to your plugins. And you can load up any file that you want to. So I had Hello World loaded up. If you have a file open, you can still type in plugin install, and that's how you can have access to your plugins. And now they're ready to go. Now that Syntastic is installed, I'd like to show you all of the different syntax checkers that are available. I've been using C++, but Syntastic has a syntax checker for probably any language that you might run into, any modern language. So if you're coding in Ruby, there's Ruby right there. Here's Python. There's an HTML library. There's Perl. Basically anything that you might be coding in, there's going to be a syntax checker available for it. And so these are all of the syntax checkers here. Let's go ahead and go back to my home directory, and let's open up a very simple Python program. So vim say hello.py. It's about as simple as it gets, so it's just a hello world program. Let's introduce a syntax error right there. So notice at the bottom of the screen that Syntastic switched to Python because it knows that this is a Python file. Now that the Autosave module and Syntastic module are part of your Vim program, let's take a look at some of the features that we can turn on or off to make things a little bit easier to deal with. The way Syntastic works is that anytime the file is saved, it will automatically check for syntax errors. Sometimes you might be writing a lot of code and you know that there's going to be a lot of errors, and you're going to be going in and out of insert mode and normal mode. And so the split window will pop open a bunch of times, and you know that you have those errors. And so you'd like to just silence Syntastic. Well, all you have to do is toggle autosave. So in the command line right there in normal mode, just say autosave toggle. And now autosave is off. And so you can come in here and you can, go into insert mode, and you can create, your function, my function or whatever. And you know that you have some syntax errors. Well, it didn't autosave, so Syntastic didn't check the code. Well, I'm going to save manually, and so now Syntastic kicks in and I see the error. If I don't save and I just leave autosave off, then I don't see this split window pop open. And then I can just toggle or autosave, toggle, so now it's back on. In this part of the video, I would like to demonstrate how you can use the split window with Syntastic to jump to the errors in your code. So I have a demonstration of inheritance in this project, and so I have the rectangle class and the derived class, which is the box class. So box inherits from rectangle. So let's go ahead and open up the base class and the derived class in tabbed file format. So vim box.hpp, box.cpp, and then the base class rect.cpp, and then I'd like it to be in tabbed file format, or tabbed window format, so that's -p right there. So now I can see all four of the files, and I can go to different tabs with tab N, and then tab previous to go to the previous. And then if I'd like to go to the third window, I can say tab N3. And so then that takes me to the third tabbed window. Okay, so when we were in the box implementation file, box.cpp, we could see that there were 2 errors. And I can see the first errors on line 9. But if I look down in the split window that Syntastic has opened up, it is telling me what the error is. And it goes off the edge of the screen. And so I've made my screen small so that you can see the text on YouTube. But let's jump to the window, to the split window. And it's just like any other split window. I can do Control W to jump to the split window. So now when I type return on that first error message, it's going to jump to line 9, and it's going to tell me what the error is along the bottom of the terminal window. So now I'm back on line 9 in the source code file, and it's telling me that there is no such thing as height with a capital H, but there is such a thing as lowercase h, height. And so let's do tab previous to see the header file, and we can see that height on line 8 is indeed a lowercase h. So I have a syntax error in my implementation file. So tab next. Let's go ahead and take a look at how I can switch to the other errors in the code file. So Control W to go to the split window, and then I want to go down to line line 3, or error number 3, and it's telling me that there's an error on line 26. So now all I have to do is type return, and it will jump down to line 26, so I can fix that error. So let's go ahead and replace. So I'm just going to type R, and I'm going to type a lowercase h. And so since I'm in command line mode, it's saved automatically, and so Syntastic updated the error window for me. So now I can go back to line 9. So I'll just do 9 capital G to go to line 9, and then I'll replace with lowercase h. So I fixed both errors, and so now the Syntastic error window went away, and so now I know that all the errors are fixed. So that's how you can jump to the errors in your code, and it's just a regular split window, so you can just type return on the line where the error is, and it will jump right to it. In the last part of this video, I'd like to show you the key mapping that I have set up so that I can compile my code and I can run the executable after it's compiled. I could also start up GDB on the command line, and then if there's a make file, I can type F6 for make. Okay, so I have F2 set up so that this command will be placed on the command line. So if I place an exclamation mark in front of it, that means execute the command in the shell. And so this is a program, it's a bash shell script that I have set up. And so it's called comp, and it's in my bin directory, and we can take a look at that in just a second. So if I'm working on a single source code file and I want to compile it, I can type F2. So I can map any key that I want using map this way. So let's say I would like to map it to F7 or something like that. I could just change that to a 7. And then if I would like to do a control key combination, like for example, if I wanted to do Control C on the keyboard, I could say capital C dash C. So I could hold down the control key and type a C, and then that would cause my compile script to run on the command line. So this is how you can do a control key combination right there. And then if you'd just like to be able to press a key in order to have the command executed like a single key, you can just type whatever key that is. So now if I save my my vim rc file, anytime I type C in normal mode, it will execute this compile command. Okay, so this means, the exclamation mark means execute the command on the shell, in the shell, and then the % is the current buffer, the current file that I'm working on in Vim. So it's kind of like the name of the file that is current. So compile the current text file, or the current source code file. Okay, so now I've changed that to a C. Let's put it back to F2. And let's demonstrate this using the Hello World program that I opened up earlier. So there it is right there, Hello World. So vim hello world.cpp. And then if I want to build it, all I have to do is hold down the function key and then type F2. And there's the command to build it right there. So the current file that I was working on was hello world.cpp, and so that % was replaced with the name of the current file. So now I have built my program, and -o build is, so the executable is now called build. So if I want to run it from Vim, all I have to do is type F3. So it's a very simple program. So it just says hello world. So there's the execution of my program because I held down the function key and then typed F3. Okay, so depending on your keyboard, you might just be able to type F3. Okay, so let's go ahead and modify the .vimrc file so we can take a look at the control key combination, or just the regular key regular key press that you want to map to whatever you want it to do. So let's go down to the end of the file, and let's say that instead of typing F2, I would like to just type the C key. So now I've updated my vimrc file, and then let's open up Hello World. All I have to do to compile it is type C in normal mode, and it compiled my code for me. Okay, so there's a lot of different options that you can use to map different keys to different commands. So let's open up the vimrc file, and we'll replace the F2 that I had there before. I'll replace C with F2 again. And now let's take a look at the actual shell script. It's in my bin folder so that it's executable, and so my bin directory is in my path. And so let's take a look at comp right there. So vim comp. So it has the shebang at the beginning, and it's a bash shell script. And when it's invoked on the command line from Vim, Vim will not actually let you know what it's doing. And so I wanted to be able to see the command that was going to be executed, so I put an echo of the command first, and then here's the actual command that gets the job done. With a shell script, when you have command line arguments, you put a $ in front of it. So the first command line argument is going to be $1. And so that just will substitute the current file name because that's going to be placed on the command line. So that's the argument to this shell script. Okay, so that is my compile command. Let's switch to the other project that I have with the inheritance example, and let's take a look at the key combination one more time. So vim.vimrc. Oops, I'm in the bin directory. Let's move to my home directory. So vim.vimrc, and you can see that I have F6 set up so that I can do a make command on the command line right there. So this is handy for when you have a multi-file project. So if you just have a single source code file, you can just compile it using the shell script, But if you have a multi-file project, it's probably easier to create a make file and then just set up a key map or map a key so that you can invoke the make command right there. So let's switch to the other terminal where my project is. First, let's quit. So here we have the project that I had a couple of errors in that we fixed. So now it's lowercase h. So let's go ahead and take a look at the make file. So quit all, and then vim make file. So this make file will compile each source code file first into an object file. So we're going to create main.o, box.o, and then rect.o based on the implementation files. And we're going to, and the main source code file. So these are the two implementation files, and then this is the main function file. And then this command will be used to execute the actual command to create the executable. Looks like I might have a mistake here. I'm using build for my other script. So let me update this so that it doesn't call it program. Let's call it build. And so now those two commands are going to match. Okay, so I've updated my make file. Let's quit, and then let's reopen all of those files. And now all I have to do is type F6 in order to invoke the make command. So F6. Okay, so there's my make file in operation, and so it created the executable called build. And now if I want to run it, I can just do F3. So that it's pretty simple output for this inheritance example, but that's the output right there. So I ran my executable from within Vim by pressing F3 because that's the key mapping that I had turned on. Okay, that about does it for all of the items that I wanted to cover in this video. So I hope it was helpful, and thanks for watching.